We've been using artificial intelligence. I think we will bring AI to everyone. Executing with AI for a long time.
We've been waiting for Apple to do something about AI, right? But they're not really doing anything. Or are they? Hey Siri, build me an end-to-end AI-powered Apple website. And make no mistakes.
Sorry, I don't understand.
Huh? They don't even have a support chatbot on their website.
Sorry, I don't understand.
Hey, shut up. Let's rebuild this website from scratch and bring Apple into the AI era. Think of this as an end-to-end full-stack SaaS project. Here is the stack. React for the frontend, REST API for the backend, and PostgreSQL for the database. For the AI brain, we will use the ChatGPT API, all orchestrated by LangGraph. Let's dive right in. First off, we are going to build an intent agent. This will understand the user's intent when they send a message in the chatbot section. Is the user asking something about Apple? Do they want a general chat? Or is it something completely out of context? If the user asks something relevant to our business like where is my order, we will route them to the support agent. This agent uses RAG to read Apple articles. If the user is still not satisfied, it creates a ticket for the support team and returns a JSON output. If the user says, I wanna buy a MacBook Pro, but which one, we will route them to the sales agent. This agent will have access to the company database and will be able to query the inventory. If the user just wanna chat, we will route them to our low-cost simple model. It's like tiny model. In our industry, this is called model routing. You switch the model based on the incoming question, so you don't spend same amount of money on every request. We don't need to run our most powerful model just for the word hello. Let's start coding. First, we will create Apple's famous minimalist black and white design. We will try to design our website interface as much of this simplicity and elegance as possible. Let's start by installing the necessary libraries. I will be using React and Tailwind for the front end. First, we will set a white background for the very back of our website. It's not exactly pure white. Instead of the pure white, FF white, Apple opted for FB white or slightly darker of whites here, so I did the same. Next, let's move on these sections. Each section uses a different color and has a distinct purpose. Let's take care of those. First up here, we are building the top navigation bar. Then we built the main section where iPhones are listed, followed by the section with more detailed iPhones. It actually took me quite some time to replace Apple's exact design. Don't let the simplicity fool you into thinking it's easy. And it's finally done, but as you can see, it needs a few tweaks. After making the final tweaks, let me give you a blind test. Is the real Apple website on the bottom right or the top left?
Yeah.
Just as you guessed. You did guess that, right? It was the top left. As you can see, we can safely say we did a great job on the front end of the iPhone page. I would even say I did it better. Anyway, now it's time for the order page. When we try to navigate to the purchase page from these images here, we naturally face a completely blank page because we haven't finished the purchase page yet. On Apple's website, this page looks like this. As you already know, a page comes up where we choose the device's model, color, and storage. Now we are going to try to build an exact replica of this page. Let's get this done. This design is completed. Now, I also tried to replicate Apple's bag management as closely and flawless as possible. Once the model, color, and storage are selected, clicking Add to the Bag button sends the product to the cart. We can add other products if we want to, and the items in our cart won't disappear during this process. Even if we refresh the page, you can input the item quantities right on the cart page, and the system calculates the total amount to be paid by multiplying the quantity by the price and adding up all the items. If we remove items from here, they are deleted from the cart and no longer reflected in the total price. So I tried to make it as close to the production as possible, and I will spend some time on edge cases later to keep it as clean as it gets. Wait a minute, $1 million? What the hell? Now, it's time to securely buy the items in our bag and handle this process like professionals. For this, we first need to design our database. As you know, we are using PostgreSQL as our database. Here is how I plan to design. Our database will consist of 3 tables: user, order, and product. The user table will hold the ID, email, first name, last name, phone number, address, hashed password, and is verified status of the user registered in our system. This table will be related to the order table because when an order comes in, we need to know which user replaced it. In the order table, we have the order's ID, the user's ID, the order total amount, the item summary, meaning which products were bought, and the order status. And our product table contains the product ID, name, and quantity. This table is actually our inventory system. So this is where the stock quantities of all the products company has on hand are kept. For example, as a company, we have 5,000 iPhone 17 and 2,000 iPhone 16 in stock. After every incoming order, this gets updated and our on-hand product stocks change. Our AI agents will be interacting heavily with this table. Now, let's see the system in real time. Let's take a look at how the system works together. Let's select our iPhone 17 Pro Max, soft pink, 1TB product, add our items to the cart, and as we proceed to checkout, it asks the user to either register or log in. First, let's try to log in with an account that isn't registered in the system. When logging in or registering, the system asks for an email first. If the user doesn't provide their email in the correct format, the system gives a warning and doesn't let them proceed. As we continue the login, the next step is the password, but since the system knows this user isn't registered, it will throw an error. Alright, now let's register to the system and keep everything moving as it should. During the registration phase, first the email, then the first name and the last name, followed by the phone number, and finally the address information where their package will be delivered. No. We are not ordering an iPhone to the White House. Finally, it asks to set a password, and similarly, if the password doesn't meet the rules we set, the system gives a warning. Since it cannot be stored directly in our database, so that when the hackers branch our database, everyone's password aren't just sitting in plain sight, is subject to an encryption process. Here, the password is hashed with the bcrypt algorithm, and this hash password is represented by the bcrypt algorithm like this. This changes every time generated, and the hash password is what gets saved to our PostgreSQL database, not the plain text password. All this only happens if they verify their email. I built an email verification system here using the Resend API. After the user fills out all their info and clicks register, a code is sent to their email. A 3-minute TTL is kept in Redis, and after they verify it, their information is actually saved to our database. You can see the database here. The registered person's email, first name, last name, phone number, address, hashed password, and the information about if users verify their email. We will pass an element from the other table into this column. When the user does everything correctly and successfully registers, our system gives them a token. I used JWT, so JSON Web Token here. Tokens are used to authenticate users and authorize them. Then we store this token inside an HTTP only secure cookie so that it can only be read by our backend, which is Fast API. The expiration of this token is 15 minutes and the refresh token lifespan is 7 days. And this is how our backend looks. We have 6 endpoints: sign up, verify OTP, which is email verification, login, logout, create order, and get orders. On the payment page, we are currently running a fake payment process. Once your payment is approved, the system takes you to the order detail page. Here, you can view the total price of the products you purchased and the details of your order. If you go back one step, you can see all the orders. If you are logged in, you can also navigate to this page directly from the home page. And we received an email confirming our order, which contains the order details, the total amount, and a confirmation text. Now, let's continue examining our database. We had already examined our user table. Now it's time for our other two tables, the products and order tables. As we mentioned earlier, in our product table, we see the inventory our company currently holds. For example, in this table, we have 4,999 iPhone 17 Pros, 3,000 iPhone Airs, and 7,999 iPhone 17s in stock. This will be updated after every order, and the sold items will be deducted from here. In our orders table, we view the records of the orders. For instance, the order we just placed has landed here. The total cart amount for our user with ID number 1 is $1,699. They bought one iPhone 17 Pro Max, soft pink, 1TB. The order has been paid for and it's being prepared for the shipment. If you remember, we ultimately agreed on this idea for our agent architecture. We will build this architecture using LangGraph. LangGraph is an orchestration framework that allows complex, cyclical, and multi-agent systems to achieve maximum flexibility. It's the industry standard. Today, it's used by massive companies like Replit, Elastic, Uber, and LinkedIn. We we can list some of advantages it offers as follows. Thanks to its human-in-the-loop structure, it involves human in the process and leads to the creation of more reliable systems. Its customization capabilities are very broad, allowing you to customize the agents and the agent architecture however you want. It offers professional memory management, which allows us to program agents to be more effective, smarter, more cost-efficient, and free from hallucinations. To give an example of one of the biggest advantages of this flexibility, let's say you build an architecture with Gemini, provided the tools, and defined what needs to be done. After this, when you want to switch to API-based Gemini, Cloud, or open-source local LLMs like Llama, Mistral, Qwen, all you need to do is replace the parts that contains Gemini with these LLMs. We can develop our agents in a high flexible and professional way without having to change the entire architecture from scratch. First, we are building the front-end part of this chatbot for our website. The chatbot will appear on the bottom right side of the website, just as everyone is used to. It will be able to talk to the user if they have logged in or signed up. Here are the reasons why I do this. It encourages people to register, and honestly, it stops us from burning cash by running models for every random visitors. If the user is logged in, they can interact with the chatbot from here. They can create orders with it, check their order status, query the stock, or if the user has a very complex problem, it can take a note of this and report it to real human customer service reps. For example, my order shows as delivered, but I haven't received the product yet. Let's take our first look at the chatbot. As we discussed earlier, we prompt the user to register or log in. Once the user completes the login process, the chatbot becomes accessible. Let's greet it. Hi. After making all the tweaks, here is our chatbot, ready and waiting for us. Because we have model routing here, we are using two different AI models. The support and order agents use GPT-4o, while the chat agent uses 4o mini. The reason for this, as we said before, is to use models that will not burn through money for simple tasks. Dynamically selecting a model specific to the question saves us both cost and speed. Let's have a little chat. I would like to eat kebab. Do you like also? In our prompts, we coded our agent to be multilingual. It understands every language and replies in whether the language it was written to. This way, we can welcome customers from all over the world. While our AI is in chat mode, after chatting with the user for a bit, it starts directing them to operations related to our company. Now let's look at main stock querying and order process. I want to get information about stock. As you can see, the information it provides matches our database perfectly. We owe this to the fact that it instantly connects to the database and runs a query the moment a stock related question comes in. Let me show you the real-time part like this. I'm changing the stock info of our product in our database. As you can see, it instantly reacts to the change and delivers the correct information to the user. As you may have noticed here, the AI's messages are very clear, crisp, and in a proper format. I made some improvements in the prompt and on the front end for this. Otherwise, the AI would write a message like this. Now I'm trying to trick it. I'm requesting a quantity of items that we don't have in stock. As you may remember, I just set up 10 iPhone 16s a moment ago, and we wouldn't have understood everything at first glance. Now I'm asking for 11 of them. As you can see, it correctly guides the user by asking whether they would like to buy 10 or look at other products. And I continue by saying I would like to buy 10. I'm intentionally keeping my sentences short to test if it gets confused. It replies that I need to choose the storage and color specs to proceed, meaning it continues to guide me correctly. It confirms our selection and asks if we will make the payment process with our saved payment method. Finally, it says that it successfully handled the payment and complete the order, and suggests we go take a look. Let's see. Yes, as you can see at the top, an order for iPhone 16 has been placed, and the indicator that this order was made via our AI agent is also present here. Let's see if this change is reflected in our database or not. As you can see, the 10 iPhone 16 have dropped 0 units, which means after our agent completed the order, it connected to the database and updated the stock table. Let's also look at the order table and check if it placed the right order for the right user. Yes, we can see that the user with ID number 1 bought an iPhone 16 via the AI agent. So it successfully updated this table too. I should also point out that after AI agent takes an order on its own, it returns JSON data like this to us. This will be necessary for the full automation we will use in the future. Now it's time to look at the support section. If simple support requests regarding the iPhone comes in, our agent answers them. For example, when a simple question like how do I automatically adjust the screen brightness on my iPhone comes in, it answers itself. But when a complex support request comes in, my order shows as delivered, but I haven't received anything yet. It reports the situation to real humans. We also get JSON data in the support tickets. I think we have wrapped up most of the agentic side, and inference is working perfectly. But now, it's time to take a quick dive into the world of LLMOps. What do I mean by that? There are several tools in the industry to measure the observability of LLMs and AI agent tools like Langfuse and Langsmith. They allow us to monitor agents' behavior, trace workflows, debug issues, analyze prompt flows, track token and cost usage, and observe their performance in a production environment. They play a massive role, especially in a multi-agent or complex workflow architectures, by letting us see exactly what happens every single step. In short, they provide insights like which user wrote what message, how our agent classified that intent, which model we used, what kind of answers we gave, how much we paid, how many seconds it took to reply, and our exact agent cost per user. With all this data, we can see if our intent classification is accurate, pain point areas for improvement, and figure out exactly which question broke which agent. Ultimately, this allows us to continuously improve the system, keeping it constantly evolving, flexible, and learning. And for this project, since it's open source, we will be going with Langfuse. First off, I should mention that, as you might remember from our diagram, our intent agent is the first to greet the incoming message. We have 4 intents in total. The intent of incoming message can be chat, order, support, or unknown. For example, let's assume you wrote a message saying hi to our agent. The roadmap for this message in our architecture look like this. The message will first enter the LangGraph. Then our intent agent function will start running. After that, our intent agent, which uses ChatGPT as a model, will work to understand the intent, and it will route the message to the relevant agent based on the detected intent, whether that's support or order. Since the word hi come through in this example, our chat agent will step in, and then our chat agent will generate a response for the user using ChatGPT. Now let's observe the system through Langfuse. Let's test our intent and see how the process works on Langfuse. We will get a clearer picture of what Langfuse actually does. Let's do a quick introduction to Langfuse. From the session section you can see on the left, every new chat opened by the user comes in right here as a new session. While in the users section, as you might guess, individual conversations for each user are stored. For example, since I chatted with our AI using this email, this record is right here. The page is highly useful for analyzing who had what conversation. But for now, we are heading back to the session section. Let's start with chat intent first. Let our user say hi. And now, let's see Langfuse to see what happened. In Langfuse, we are greeted by a page that mirrors our architecture. As you can see on the left, it's exactly the same page we just described in the architecture. First, the input arrives in Langfuse, the intent detection is done with ChatGPT, and finally a response is generated with ChatGPT in the chat section. As you can see here, the total cost is stated right here. This is the cost for intent, and this is the cost for ChatGPT generated for the response. Intent detection took 1.94 seconds, while generating the response took 1.63 seconds. The total time is also written right here, where the total cost is. So in the total, the conversation took 3.59 seconds, incurred this cost. In the LangGraph section, as you can see, my hi message and AI's hello, how can I assist you today message are visible. Here, it clearly states which user this conversation was held with using the user ID. When we come to the intent section, it correctly classified hi message as a chat, just as we expected. Moving to the chat OpenAI section, we can see which model was used for intent detection. And here, it was correctly done with our mini model GPT-4o mini. Then, in the chat OpenAI section, the response is generated. We see that GPT-4o mini model was selected again, and user's hi message was answered with the mini model. This proves that the project is working correctly. As you might remember, responses to chat messages were supposed to be provided by the mini models. So, to summarize, we reached the following analysis here. First of all, we kept records of who made this conversation. Then, we detected the hi message as a chat intent using the mini model in 1.94 seconds, and we generated the response message hello, how can I assist you today in 1.63 seconds, again with the mini model at this cost. Now let's do another test for the order intent. As you can see, we stated that we want to place an order, and here we expect intent to be order. When we enter Langfuse, since this is a new chat, a new record has opened in the session section. When we look at the details, we can see the conversation. Once again, we see the total and individual cost and the durations. The intent agent successfully flagged this intent as order here. Intent detection was again done with the mini model. However, unlike the others, the response to this question was generated with the powerful 4o model, not the mini model. It means model routing is working and saving us from extra costs. We have successfully tracked all our agentic process with Langfuse. You've probably noticed by now that we have a much more deterministic, trackable, and scalable system, and you can see exactly how everything runs inside Langfuse. Now, let's keep making our SaaS even more realistic. Next up, the OMS or order management system, and the solution we are going with is the one that immediately comes to mind. What I'm talking about is Shopify. We are going to connect Shopify directly to our database. This means any order come in, whether manually or through our AI agents, will drop straight into the Shopify dashboard. From there, we can manage the orders, update the statuses, get one step closer to a fully functional, real-world e-commerce platform. I planned the order management system like this. As you know, orders are placed on our website in two ways. First, manually selecting your product and proceeding, and second, with the help of AI agent. In both cases, the order lands in Shopify. For a manual order, after going into the products and specifying the features, you place your order and the order drops into the My Orders page. The same order with the same details drops into Shopify as well. The user receives an email from our website confirming the order, while the site admin receives an email from Shopify about the incoming orders and its details. On the first page of the website, we can see who placed the order, the total price, the order status, and how it was placed via agent or manually. When we look into the details, we can also see information like the address and email. From here, we can change the status of order and handle professional order management. Nothing changed for an order placed via agent either. The process continues in the exact same way. The agent provides the details of the incoming orders as a JSON. We pass this data along to Shopify, and exact same process runs there too. And that brings us to the end of the video. It was a seriously detailed one with a lot of moving parts. We built an end-to-end website, added an agent architecture, slashed the costs, integrated a tracking system, order management system, Redis, and so much more. But I think there is a final reality check. Connecting an AI agent to an API and showing off a demo is only 10% of the job. The other 90% is making the system production ready. Because in the real world, systems don't just run on happy paths. Let's look at ultimate edge cases. Imagine there is exactly one iPhone 17 left in the warehouse. In the exact same millisecond, a regular customer on the website and a user chatting with our AI agent both add it to their bag and hit pay. Who gets it? Does the system crash? Does the stock go negative? In this project, by strictly following ACID principles at the database level, we implemented row level locking. The first request grabs the lock, the second one waits in line, and we completely eliminate that chaos. We call a race condition, and it doesn't stop there. Behind the architecture you saw today, there is a serious security and performance layer. We put our system behind an API gateway and a reverse proxy. When sudden traffic spikes hit during periods like Black Friday, our load balancer smartly distributes the traffic, while rate limiting and throttling mechanisms stop malicious bots from crashing the system. For customer security, alongside our JWT infrastructure, we implemented CSRF protection and MTLS encryption between our microservices. There are so many other production-grade optimizations I haven't even mentioned. But that's it from me for this video. We will definitely dive deeper into these kind of topics in the future videos. To make sure you don't miss out on what else we can build, please do not forget to subscribe, like, and leave a comment. You can reach out to me through email or my LinkedIn account in the description of this video, or my Upwork profile where I offer support for professional works. Until next time, take care.